Our last example on radicals leads us into solving quadratics. So we're first going to factor. Example A, we've got a difference of squares, so we factor that into its conjugates. And we set each binomial equal to 0. I've kind of shortcut this, so if you've had a hard time following me, I'll show you the long way this time. And then you solve each equation. So we're going to add 1 and divide by 3, or we're going to subtract 1 and divide by 3. So those are our two solutions for our quadratic equation. For part B, we have to get it equal to 0 before we can factor. So again, I'm going to reorganize this so that my leading coefficient is positive. So I'm going to add 25x squared and subtract 20x. But I'm going to organize it so that all of our terms are on the left-hand side, just because that's what we're used to seeing when we have our quadratic equation set up. So I added 25x squared to both sides, subtracted 20x from both sides, and 3 stayed on the right-hand side. I just switched equations. That looks really confusing. Let me change this. So this is the AC method because we have a leading coefficient and it does not factor out. So what multiplies to 75 and adds to negative 20? Well, the obvious choice would be 25 times 3, but that's not going to give us a negative 20. So another option is 15 times 5. So we would need both of these to be negative in order to add to the negative 20 and multiply to a positive 75. So we factor by grouping when we're using the AC method, meaning we have a leading coefficient. The first two terms have a common factor of 5x. And the second two terms have a common factor of negative 1, so we can get the same signs as our first binomial. So then we've got 5x minus 3 factors out. 5x minus 1 was left over. Set each binomial equal to 0. And solve. So we have adding 3 dividing by 5, or adding 1 dividing by 5. So those are our two solutions for this quadratic equation.